lesson 10.6, equations of circles. Okay, so we've been dealing with circles, right? But we can also write an equation for a circle, okay? So as long as you know the radius of the circle and the center of the circle, you can write an equation that describes the circle itself and all points on the circle. Okay? So we know that the radius is r, and that it's the distance from the center to any point on your circle. Okay? So we call the radius r. And then we are going to say that the center of our circle is located at a point h, comma, k. So an x and a y coordinate. Okay? Then, if you have a point on your circle, and we know all points on a circle are x, y coordinates, then we can use the distance formula to find an equation for the circle. So we know that the radius is the distance between a point and the center. So using the distance formula, we know that the point would be x minus the x coordinate of the center plus squared minus y, plus y minus the y coordinate of the center squared. Okay, it's just the distance formula. And we know that the radius is the distance from the center to a point. So these are the two coordinates we're using. Okay, and then getting rid of the square root, we end up finding out that the radius squared is going to equal x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared. Okay, so this is the equation of a circle in standard form with the center at hk and a radius of r units. Okay, so then just practicing writing those equations. Okay, so you want to write the equation of a circle with the center at -5, 0, and a radius of 4.8. Okay, we're just going to plug it into our standard form. This is standard form, the r squared. Okay, well then it's going to be the radius squared, so 4.8 squared is equal to x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared. And then we just simplify it. So 4.8 squared is 23.04. And then x minus -5 would be x plus 5 squared. And y minus 0 is just y, so we get y squared. And that would be the equation of our circle with a radius of 4.8 and the center at -5, 0. Okay? So if you get the center and the radius, it's just a matter of knowing that this is h and k and r and plug them in to get the equation of the circle. All right. The other thing you can do is if you have a point and the center, you can write the equation that way. Okay? So we know we have a point, and the point is 2, 1, and it's on the circle, and the center of our circle is at 4, -3. We want to write the equation of this circle in standard form. Okay? So to write the equation of a circle, you need the radius and the center, because the center is hk. So given the center, we already know h and k. All right, so we know that h is going to be 4 and k is going to be -3. But then we need to find the radius. So the radius is the distance between a point, or the radius is the distance between a point and the center. Okay, so distance formula, we're going to use these 2 points, because it's the center and a point, to find the radius. It's going to be 4 minus 2 squared plus -3 minus 1 squared. 4 minus 2 is 2, Negative 3 minus 1 is negative 4. 2 squared is 4. And negative 4 squared is 16. So the radius is the square root of 20. You don't need to simplify that, okay? Because when you plug it in for the equation of the circle, you're going to square it. Okay, so in standard form, the circle is r squared equals x minus h squared plus y minus k squared. So r is the square root of 20, so r squared is just 20. So the equation of our circle is 20 is equal to x minus 4 squared plus y plus 3 squared, because it's minus negative 3. So we're just plugging in h and k and r, and we get the equation of our circle. Okay? Pretty straightforward. Then, once you have the equation of a circle, you are able to graph it, right? We always end up wanting to graph things, okay? So, for the graph, the first thing you need to do is plot your center. Okay? Then use your radius to get 4 points. I say 4 points because if your center is here, the radius you could count over to the right, to the left, up, and down, however many units the radius is, to give you 4 points, and that will give you your circle. Okay? So if we want to graph x minus 3 squared plus y plus 1 squared equals 4. We need to know the center and the radius. Okay? So standard form, x minus h squared plus y minus k squared equals r squared. So it's x minus 3, so h is 3. It's y plus 1, so k is negative 1. And r squared is 4, so r is 2. So here's our center and our radius, okay? Then, from there, we're going to graph it, okay? So we said center and radius. All right, so here's our coordinate plane. The center is at 3, negative 1, we said. Okay, and the radius is 2. So from here, I'm going to go over 2. There's 1 point. Then I'm going to go up 2. So 1, 2. There's a second point. I'm going to go to the left 2. 1, 2. And I'm going to go down 2. 1, 2. Because this is the radius. So it's 2 units, 2 units, 2 units, 2 units. And there would be my circle. Pretend it's on graph paper, right? So it's an even graph. Should look round, not really oval, okay? More like this. So center, I went over 2 units, up 2, left 2, down 2. And I was able to graph my circle. Okay? Then when you look at your circle, you have points on the inside and points on the outside. Okay, anything here would be on the interior, and anything here would be on the exterior. Okay, so you can take your equation and decide whether it's on the inside, outside, or on your circle. Okay, and you do that by using your equation. So x minus h squared plus y minus k squared equals the radius squared. So if you plug in a point for h and y, or x and y, and that becomes a true statement, so it's equal, we would say that the point is on the circle. Okay, if you plug in your point and you find out it is less than the radius squared, it's on the interior of your circle. And if when you plug in your point for x and y, you find out that it's greater than the radius squared, it's on the exterior of your circle, the point. Okay? So looking at that, so if it's equal, it's on. If it's less than, it's on the inside. And if it's greater than, it's on the outside. So if the equation of my circle is x minus 2 squared plus y plus 3 squared equals 4, and we're checking to see if the point 2, negative 4 is on, inside, or outside the circle. What you do is you take your equation and you replace x and y with the point. So we're going to check to see if 2 minus 2 squared plus negative 4 plus 3 squared, and compare it to 4. So 2 minus 2 is 0. Negative 4 plus 3 is negative 1. And 0 squared is 0. Negative 1 squared is 1. And 1 is less than 4. So that tells us that this point 2, negative 4 is on the interior of our circle. Okay? We can check the next point. The point 3, negative 1. Where is that? Is it on our circle, inside our circle, or on the exterior of our circle? So again, you plug in the point for x and y, and then you compare it to the radius squared. So 3 minus 2 squared plus negative 1 plus 3 squared. How does that compare to 4? So this would be 1 squared plus 2 squared. 1 squared is 1, 2 squared is 4, and that's going to be bigger than 4. So that tells us that this point is on the exterior of our circle. Okay? And then let's check the point 2, negative 5. Okay, so plug in the point for x and y in your equation and compare it to the radius squared. So 2 minus 2 squared plus negative 5 plus 3 squared. How does that compare to 4 squared? 0 squared plus negative 2 squared. So 0 squared is 0. Negative 2 squared is 4. They are equal, so it tells us, because it's equal, it tells us that this point is on our circle. Okay, so we're able to write equations of circles given the radius and a point, or not a point, the radius and the center, or the center and a point. We are able to graph our circles in standard form, and you're able to tell where a point is in relationship to the center, or a relationship to the circle, not just the center.